Hi everyone, Dan here and welcome to this developer update. Today we're going to be looking at the RØDECaster Pro II, and joining me to talk about it is the head of the R&D section of our new product development team, Pieter Schillebeeckx. Pieter basically is our head boffin. Pieter, welcome, glad to have you here.
Thank you.
So today we're going to be talking about the RØDECaster Pro II, and we're going to be taking a look at what goes on inside. That's right, we are literally going to take it apart and show you exactly what happens under the hood. Now, this is something we've had a lot of questions about on social media. Some people have even started doing it themselves. But please don't take your RØDECaster Pro II apart. It will invalidate your warranty. Instead, just sit back and watch as Pieter takes it apart and explains everything that happens inside in front of your eyes. So Pieter, I see you've got your screwdrivers.
I have my tools.
And we're ready to start. Just before we start taking it apart, the RØDECaster Pro II builds on the legacy of the RØDECaster Pro I, which is obviously a hugely successful product which revolutionized podcasting. Because remember, back in 2018 when it launched, there was really nothing else like it on the market that brought together so many functions into a single integrated unit. Now, the RØDECaster Pro II has some visual similarities to that original RØDECaster Pro, but just tell me, how similar is it?
Not at all. It's different in every single aspect, from mechanical to the electronics we use to the software we deploy.
So quite a different animal.
Very different indeed.
That's right. So I think that really talks to how we approach innovation here at RØDE, with always looking for the best way to find new technology to answer the question, rather than just relying on iterating the technology we already have. So how do you go about choosing a technology platform or new technology sort of basis for a new product such as this?
Very often we start by looking outside of the audio world, and we look what other technology companies are doing, what kind of technology they're deploying, and that's very much the case with the RØDECaster Pro II. It's built on very, very modern, very, very powerful processors that you'll find in tablets, mobile phones and things like that.
Amazing. Well, let's get into it and start taking it apart. Pieter, take it away.
Okay, we're going to start by taking the fader knobs off. Don't do this at home.
So those fader knobs are made of aluminium or plastic or metal?
They're made out of cast zinc. They have a piece inside that grips onto the fader so that they don't come off easily, hence me having to put a screwdriver underneath to gently pry them off.
Now, I know when this was in its original development phase, there was a lot of discussion internally about the actual faders themselves and how smooth they were and the mechanical design of those sliders. And it was something we spent a lot of time on. How was that approached?
So there's a couple of things. First of all, it's about constant feel all the way from the top to the bottom, and these remain smooth through the whole range. The next one is side-to-side wobble, and you know, if you feel a fader for the first time, you think, oh, actually that feels quite loose. But if you actually go to lots of mixing consoles, there will be a lot more side-to-side wobble. So we really try and eliminate side-to-side wobble and the constant smooth feel throughout. So we completely develop the fader from the ground up to get that constant feel.
Yeah, and as you say, they do feel very solid. That lack of wobble, as you called it, really helps to make it feel very accurate and easy when you're sliding them up and down. Wow, amazing.
So I will continue taking these knobs off here. So what we're going to do next, I'll move these to one side, is we're going to turn the unit over, and we are going to remove the feet which cover the screws that hold the whole device together. And we shall now undo the bolts that hold the whole thing together. We are now good to take the unit apart. There we go.
So amazing. So this is the back panel, and obviously you can see the sort of front part of the shell. So it's basically like a clamshell. It goes together in two pieces.
So all of the parts used within this RCP2 are molded here in-house in Sydney in our state-of-the-art injection molding facility. And even more, they're actually tooled here. So the tools that are used to create the parts are all made in-house to great precision.
So the actual molds, the thing the polymer is injected into, they're actually made here, which is
absolutely.
Amazing.
So start to finish. So we start with a little sketch on a piece of paper, and then we do a full 3D model, a detailed model. It goes to the tooling shop where they make the tool, and then it goes to the injection molding facility here on site, and we mold the parts. And it's then reinforced with a piece of metal that we use to allow you to use a VESA mount or to go straight to a 3/8-inch mic stand.
Yeah, it's very strong, isn't it? Do you know what sort of polymer it is that we use and what sort of standards we use to create it?
We use PC ABS, so polycarbonate mixed with an ABS plastic, and it has a lot of great qualities. So it's extremely strong, but it has a little bit of flexibility in there. So when it's dropped, it can absorb shocks and things like that. So it makes for a very, very strong shell because the bottom part is made out of polycarbonate ABS, but so is the top part. So when they mate together and they're screwed together, you end up with a very, very strong housing for all the delicate electronics that's inside.
Yeah, amazing. So as it was explained to me, it means that when you drop a machine like this, it almost bounces compared to, say, a metal chassis, which will just deform when it hits the ground.
Yeah, so basically it has a little bit of give. It will then bounce back and go back to its former shape, where if you have, for example, an aluminium or a light steel body, it would dent and deform and then have an impact on the electronics inside.
Great. Anyway, let's move on and have a look at what's inside. This is the exciting part.
I will put this to one side. Now we have the inside of the unit, and as you can see, it is either all connected by flexible PCBs in between the various boards, or a couple of RF connections. So there is no hand-soldered kind of connections that can go wrong inside of the unit, which really makes for great reliability.
So these circuit boards, again, these are all manufactured here in Sydney, that's right, isn't it?
Yes. We have our own state-of-the-art SMT facility where every single component is placed and every single PCB is tested here on site before getting programmed and then fully assembled.
Great, amazing. So what are all these different PCBs? What do they do?
Well, there are 4 PCBs in total in this device. Over here, we have the heart of the device, and it's what we refer to as the digital board. And that's where all of the hard lifting happens. You know, this is where your USB connections are, your network connections, but also all our wireless, like the Bluetooth, the Wi-Fi, and of course, the main processor and the onboard memory all live on this PCB. To the right-hand side, we have the audio PCB. So that's where our brand new 40s unit Revolution microphone preamplifiers are housed, as well as our analog to digital conversion and digital to analog conversion for our line and headphone outputs. And then the larger PCB here houses the faders, the RGB LEDs, the pads, buttons, and things like that.
So there's three boards in total then, in terms of how this is?
There is a 4th one which simply holds the 4 combo jacks, but yes, there's 3 key PCBs.
Amazing. And just looking at that, the heart of it, as you called it, where all the processors are and also all the brains of the unit kind of sit. I mean, just looking at the size and how it looks, I mean, it has a distinct sort of mobile phone look about it, to my untutored eye.
Yes, and that is not unsurprising in that the processor we use is something that you could use to create a mobile phone. It's a state-of-the-art quad-core processor, and we developed the whole software framework specifically for this processor to give us unparalleled amount of processing power when we are creating all the different audio mixes.
Amazing. Well, we'll talk a bit more about that as you continue to remove those parts. I want to see what happens next as you take off the next part.
So the first thing I'm going to do is I'm going to undo the 3 flexible PC connections that connect the digital board to all the other ones. And then there are also 3 RF connections for strategically placed antennas for all the 2.4 gig systems on board. So I'm going to start by removing those, and then we shall remove the screws so we actually can take digital PCB out. So that's 1 RF connection. That's another RF connection, and that's the 3rd one. Then we will carefully lift the latches of the FPC connectors.
Now these boards are all tested prior to being assembled into the RØDECaster Pro II via a process called ATE, which is an automated test environment which actually tests the components on the board before they get manufactured and installed into the unit. How does that process work, Pieter? How do you test a board just in isolation to make sure that it's all working perfectly?
So there is lots of elements to that. So our ATE is made up of two key components. The first one is a bed of nails. So it's basically a whole bunch of pins that go on all the test points on all of the boards. And basically we can inject signals. For example, we can apply power to the board and then we can monitor all of the other test points to make sure they are behaving as intended. So that's the first part, and that's where we start. Is the board alive? Are we getting good power supply voltages everywhere? And is everything responding the way we want? Once we've established that, we will then actually program the core processor, and that then has a whole self-test routine built in. So we will test things like memory, the storage for all our sound pads, Bluetooth, Wi-Fi, Ethernet, USB, and any other peripherals on the board. And they get a full self-test by the main processor, talking to all those peripherals and making sure they are working. And then the ATE has a piece of software integrated into it that kind of makes sure it gets the right responses.
Wow, so just a huge amount of work just to test one board. Like,
yes, absolutely.
It's phenomenal.
There's a lot of time and investment in getting the ATE right. So when the board goes onto the assembly line to build the unit, we have 100% confidence that it's a fully working piece of equipment.
Amazing. Anyway, I'm distracting you.
So I'm going to take here 2 screws that hold this board in place. So what I have now is the digital board.
Look at that, you're literally holding the brains of the RØDECaster Pro
Yeah.
II. So Pieter, what are the key components on this board?
There is a lot going on this board. As you can see, it's very, very dense. There is a lot of very small surface mount technology being used on both sides. But if we look at the key and foremost part, here we have our core processor. So this is what basically is the brains of the whole unit, and it's built around 4 very, very powerful processing cores. We also have the memory, DDR, exactly like what you have in your mobile phone or your PC or Mac laptop. Alongside of that, we have our eMMC, and that's basically a chip that behaves like an SD card. It's the same kind of technology, but we just put it straight on the board, and that's where we store all of the audio used for the sound pads and things like that. There is a whole section over here related to USB-C. So it's USB-C management. It's dealing with power supplied from our main USB power supply, and also allows you to, for example, host a solid-state drive, a USB drive on those ports. We have an Ethernet port, so you can connect this wired with an RJ45 directly onto your network for software updates and the likes. We have a Bluetooth and Wi-Fi module. So this module here allows us to connect to the Wi-Fi network, but also bring in audio or send audio to Bluetooth connected devices. And then the other parts are power supplies and there to basically facilitate all the other parts working together.
It's amazing because when you talk about that, what you're describing is a computer. Like, I think if anyone watching has any sort of working knowledge of electronics for audio, what you'd be expecting to see in there maybe is like Shark chips and sort of dedicated audio DSP chips. And yet you're not talking about any of that. What you're talking about is like, you could be describing a computer, right?
Exactly. And in essence, you could run any standard operating system on this platform. So it is in essence a computer. But if we think about what we can do on our computers, we think about digital audio workstations, they all run on those kind of platforms.
And that was a big decision, right? To move away from that more traditional dedicated audio sort of componentry to this more general purpose sort of approach, right?
Yes, we looked at the wider space, what is happening, because obviously we looked at Shark DSPs, RØDECaster Pro I runs on Shark DSP. We looked at all sorts of different processors out there. And a lot of the traditional DSPs are not really evolving anymore. People are not really spending the money on the development because everything is really moving over to processors like ARM, quad-core processors, which is what you use in a whole raft of devices. So that's why we really made the decision that to harness the power that's available there and really be on the same trajectory as all the other technology companies.
Amazing, but that has implications to the software and firmware layer that you use. Okay, is that right?
Yes, so it was a complete rewrite of the whole low-level software, and we're based on top of an embedded Linux version, and we spent a lot of time making sure that we separate the cores. So the real-time audio aspect is obviously the most important to this product. So 3 of these cores are purely used for real-time audio signal processing, mixing, audio effects, and so on. And then 1 core is used for what we call housekeeping, driving the screen, talking to Bluetooth devices, Wi-Fi devices, scanning buttons, turning LEDs on, and so on and so forth.
Yeah, so there you go. It's official. You've heard it here. There has been speculation. It is Linux running inside this box, but I guess from what you said, quite a customized sort of implementation of that platform.
Yes, it's an extremely customized implementation because we are running 11 total audio mixers all on this 1 chip.
Wow, 11 complete mixers. Yeah, I guess that's true because you've got all the sub-mixers and all the various outputs, haven't you, and all the stuff like that. Imagine if you had that on like an analog old school mixer, it would be like 150 faders or something like that. But even on digital, if you were trying to do all that, say on Shark chips, like a more traditional sort of digital approach, could you even do that?
Everything is possible, but you would end up with a lot of chips. And the challenge there is then you have to have a lot of audio pipelines between all of those chips. So it becomes hugely complicated, but also becomes limiting because it becomes a lot slower to develop on. And if we develop new features, it would become a lot more complex as we distribute that across discrete chips.
Yeah. So I think that really gives an insight into the amazing decision that was made to move to this new platform and just that flexibility it opens up. And it is about always looking to the future, what could we be doing rather than, what is it that people want. And I suppose it always reminds me of sort of Henry Ford. You ask people what they want a faster horse, and we're always trying to obviously stay a bit ahead of that to make sure we're not just working on what people maybe want now or what the applications are now, but a platform that can really into the future as people's needs change or as the environment, the audio environment changes. We can always be developing new features and new functions on this platform.
Absolutely.
Great, let's move on. What else do we have to look at and what else can we take apart?
Next, I think we should have a look at the audio board. Because we spent a lot of time on the development of the audio board.
So yes, obviously, we are an audio company. The audio performance is always going to be at the heart of this, and it always had to be quite special. But I know that for this product in particular, that was really taken to a new level, wasn't it? And a lot of this came from our chairman and founder, Pieter Friedman, who set to you, I believe, a very high bar that you had to meet for the audio capabilities of this in terms of that, analog audio capability.
Yeah, so we were set the task of making the quietest mic pre possible. And that's a tall order. Most people use a simple mic pre IC from well-established electronics manufacturers, but that is what's limiting your performance. One of the things that comes on top when you're making a podcasting consoles is that a lot of people are using dynamic microphones. So they are looking for a lot of gain in order to get that low sensitivity of the cartridge translated into a healthy level. With a lot of products out there, people end up using an extra little amplifier before they go into the mic pre, and we wanted to negate the need for that. So we wanted to make something that could be really, really high gain. In this case, we have 76 dB of gain, but we wanted it to be really, really low noise and obviously low distortion and flat frequency response and so on and so forth. So this is a fully in-house designed discrete preamplifier that we spent a lot of time fine-tuning. The original prototype was actually bigger than this whole RØDECaster Pro II, and then we spent a lot of time miniaturizing it. But we also spend a lot of time listening to it because ultimately we're an audio company, so we didn't just measure that it was lower noise, we didn't just measure that it was better, we actually took it to Sydney's most famous and best studio, 301, and put it up against the best microphone preamplifiers they had, from Neves to SSLs and all the really, really high-end ones that where one channel would cost the same price as many of these RØDECaster Pro IIs. And we got to the point, after lots of fine-tuning and listening and going back and forth, where the engineers there were blown away. They couldn't necessarily hear the difference anymore between a very, very high-end esoteric mic pre versus the one we developed, and then we translated that into this product.
Yes, and those listening sessions were actually quite remarkable. I was there for some of them, and it was, I think, the amount of time that was spent and the number of versions of this preamp we went back and had to listen to. But then, as you said, just the watching, those professional engineers who spend their whole lives in front of, the highest quality, the most expensive audio technology in the world, just kind of almost have their mouths drop open was really extraordinary. Anyway, let's get on with the show. Let's carry on.
I removed the 2 screws here, but what I'm going to do next is remove the 2 screws in the back, which hold the 4 combo jacks, because it's not just a mic pre, but it's also a line and an instrument.
And again, that's a change from the RØDECaster Pro, the original one, which just had the XLR inputs, being able to obviously take a line level source or take a high impedance guitar input or something. Is that a difficult thing when you come to designing a preamp, to be able to manage different types of inputs?
Well, yes. Basically, we have 3 completely different paths. So the mic pre is the mic pre, and it's used for microphone signals. We have a completely separate line level input path into the A to D, and then we have a completely separate high impedance instrument input. So a lot of people try and kind of, hash them all together, and they all go through the same signal path. But we wanted all 3 of them to be as good as they could be, so there are 3 completely discrete paths.
Wow, so in actual fact, you could almost say there's not just 4 preamps in here, there's actually 12.
Yes, yeah.
Well, I never knew that. You learn something every day.
So we've now loosened this board, and I shall unclip the FPC cables holding it all in.
So this board really is just holding the connectors, right? There's no active electronics or anything?
There is no active electronics, but there is some passive electronics, filtering, because obviously it's very important that it doesn't pick up any hums, buzzes, RF interference. So there is quite a lot of filtering on each of the boards, and also we have the circuit on this PCB that turns the phantom power on individually for each of the channels,
right,
which is digitally controlled, but obviously there is an analog switch in there to actually turn the phantom power on or off.
And now we can see the audio board in all of its glory.
Yeah, so if we look at the audio board before I pull it out in a little bit more detail, we have 2 areas. We have 1 area here and 1 area there, and that's basically, each one is 2 channels of discrete front-end mic pre's, and basically that's what gives us all the performance as we go through it.
When you say discrete, I think it's worth pointing out just the difference. This looks visually very different to the brains, the digital board that we looked at originally, because it has, I suppose, more inverted commas traditional components. I mean, we're looking at transistors and
yes.
things. So when you say discrete, that's what you mean. It's literally made out of individual components rather than being ICs or packages.
Yeah. So obviously we use some ICs and packages for support functions, but the main clean gain path is discrete. So it's built out of transistors, field effect transistors, and obviously all the biasing circuits and all that around there. So yeah, it's discrete components.
So that really follows the exact methodology of building a very, very high-end preamp. I mean, that's how you go about that. All those amazing preamps that were in that studio. That is the technology those are also using.
Yes, absolutely. So what we also do for added reliability is we use surface mount components throughout. So again, there is no through-hole soldering, where we can avoid it.
Yeah, so although the design might be very traditional, the manufacturing sort of processes are the most modern you can have.
Yes, but also they are transistors, they are FETs, but they have been chosen for very, very specific qualities. And this is how we get the performance, because the performance of this mic pre, the noise floor is so low that we get to the limits of what can be measured with the standard for measuring microphone preamplifiers across 150 ohm load. So we basically get to the noise of the resistor used for the testing rather than the noise added by the mic pre itself.
Yeah, wow, that's just incredible. Great, okay, well carry on. I think we're about to take it out.
I will take the audio board out. So that now comes out, and if we have a look at this board, single-sided SMT, we have 4 headphone amps, stereo line outs, we have mic pre 1, we have mic pre 2, so 2 channels each for the 4. We have our analog to digital converter, and that's a really important part of the signal path, where we convert all of the analog signals into digital, which then flows into our processor. And then over here we have our digital to analog converters, which supports all of the headphone outputs and the stereo line outputs. And then alongside here, we spent a lot of time on creating very, very clean power supplies for all of the voltage rails that are used within the analog circuitry of the audio.
Yeah, amazing. And those A to Ds and D to As obviously pretty crucial. How did you choose those components? Because there's a lot of those around, right? They're sort of, and a lot of discussion around, you know, the sound or the qualities of different brands or different sort of types.
By ear, to be honest. We tried a whole bunch of different A to Ds and D to As, and these are the ones that to us sounded the best. They gave us the best sonic quality, you know, and obviously they also measure very well.
Yeah, so I think this goes back to, you know, Rode is at its heart an audio company, and this is, I suppose, I see the digital board is where the brains is, and this is the heart of Rode,
yes,
right?
Absolutely. This is what makes the sound. When you plug in your dynamic microphone and you're running 60 dB of gain, this is what makes it sound good.
Amazing. Well, let's move on from that to where we go next.
Here's a little spacer PCB which nicely guides the RF cable. We have 3 RF connections here for different 2.4 gigahertz antennas, and basically one of them is in this bottom left corner, and I'll show it on the PCB in a little while. The other one is in this bottom right corner, and again I'll show that. And then we also have another antenna right here at the back, which is used for our Wi-Fi purposes. And again, it's a little PCB antenna that is glued to the back of the device. So I think we should go about taking out the fader board, as we call it.
And I guess this is where it gets a bit more mechanical, right, as opposed to the more electronics and sort of stuff that happens here.
Yes. And although the board at first face value might seem a bit simpler when I take it apart, it's actually really important that we get it right. And this whole board actually has its own dedicated processor to make sure that all the inputs from the faders, from button presses, is instantaneous. There is no delay, there is no lag. It is always taken care of by this processor, which then communicates that to the core processor, which will do stuff with that information.
Right, so this is not just a dumb PCB with some sliders on. There's actually a lot going on.
Yes, yeah. One of the real nice parts of having a really well-engineered plastic chassis is that we can hold the PCB in place really, really well using a lot of the details within the plastic. And you'll see when I take this board out, this is not just a very simple L-shaped piece of plastic. There is a lot of structure inside to hold PCBs in place, to strengthen it, and so on and so forth. So that's a very important part of being able to do it in plastic rather than doing it purely in metal. So now we're going to take apart what we call the fader board, i.e. the board that holds the faders up, which comes out like so. And what we can see here is that we have the 6 faders mounted directly onto the PCB. The RF cable here goes to one RF antenna over here, and this RF cable here goes to one carefully designed RF antenna over there. We have our 8 pads with the RGB LEDs in the middle. Yeah, so that's basically what is giving us our sound pads, which can be changed to color. And then again here at the bottom, you'll find all of the buttons: solo, mute, bank select, as well as the channel select buttons, the record button at the top of the device. There is a couple of other things on here other than the 4 headphone pots and the rotary controller to control the screen. But as I mentioned earlier, we actually have a processor on board this board that is constantly scanning at high speed all of the inputs from buttons, from faders, from rotary encoders, from pots, to make sure we have a very, very responsive unit. And the last thing you'll find on here is a small battery which is used to keep the real-time clock element of our processor up and running when you've unplugged or turned the unit off. So when you come back to it a week later for another podcast, the time on your recording is still correct.
Right, yeah, so that rechargeable battery just keeps the clock running inside your RØDECaster Pro II. So when you turn it back on again, obviously the clock's still correct and has the right time. And for those of you having problems with the clock on your RØDECaster Pro II, please set the time zone to where you live, and then it will work perfectly. If you check in the description below, I'm going to put a link there for how to get the clock working right, because the RCP2 actually gets the time from the internet, that's right, and resets the clock, yeah?
Yeah, so the time zone is very, very important on RCP2 because we will reset the time every time it connects via Wi-Fi or network, but also over USB. So when you connect over USB, it will get that information from your computer, but it does not get the time zone information. It literally just gets the time. So it will try and reset if you don't get it right.
Yeah. So get your time zone right. Top tip there, folks. Okay, so that's the fader board,
which I'll put over here. And from here on in, there are a few parts left, but one very important part. We have all the buttons, and they're made out of silicon. And when you looked at the fader PCB, we have these small gold-plated contacts, and basically these little black carbon pills that are overmolded in the silicon, when you press them down, they make contact with these gold little pads, and that's basically how we detect the button press or something like that. So basically the same technology is used for mute solo bank select, for the channel select buttons, and the record button. So all made out of silicon. Then over here we have a very important part of the RCP, which is the smart pads. And basically we have a carbon film, so that makes contact again with the PCB. And as we press down the silicon pads, that is making contact. So there is not a lot of travel there, so you can have a very, very responsive, very quick kind of activation of pads.
So this on the fader board, you have these conductive surfaces.
Yep.
And then basically this carbon is also conductive, and basically you're just pushing that carbon down onto the surface of the board, is that right?
Yes, correct. And this green that you see all around is actually of a slightly higher height. So basically in a resting position, it is lying on the green surface, so there's no contact being made. But if we then press with the silicon button on the carbon part, that will then depress and make contact.
Right, yeah, I see. And it was those iconic pads that, really define the sort of look and function of that first RØDECaster Pro. Up until that point, those sort of pads had never really been seen on a mixing console. They were only really associated with, musical instruments like samplers or drum machines. And they're all one piece too. I wondered whether they were one piece or whether they were
and they're actually quite
together.
Heavy.
Yeah, they are.
Yeah.
That's heavy. Wow. And they're kind of pleasingly floppy. Like a bar of chocolate. You could break one off and eat it.
I wouldn't suggest that. Here we have the light pipes. So these are the 4 light pipes around the headphone pots, and then the light pipe around the rotary encoder.
So a light pipe, what it does, it basically you have one LED, right? And what the light pipe does is effectively direct the light into a ring shape or a rod or whatever you need. So rather than being like a little point of light, you get that nice diffuse color. Is that right?
Yeah, but we actually use 4 LEDs for every single headphone pot or rotary encoder, so we get a very uniform light all the way round. We're now left with our top chassis with the metal inlay, but the last part is obviously the LCD screen, which is a high resolution 5.5-inch screen with an inbuilt light sensor. So if you have that turned on within your software, you can kind of dim, auto dim, depending on the environment you're in. And there is also a little haptic engine in there, which I like to use for press and hold functions. So for normal functions, I think, I generally have it off, but you can choose to have it on for every button press. But it's very nice for press and hold, so okay, I achieved my press and hold, and there was a little buzz on the finger.
The last, I guess, major component to take out is the screen, which you've just described. Can you do that? Can you take the screen out?
Not without completely breaking it. So it is glued in with extremely strong glue that, again, you would use in mobile phone construction, where the screen is glued onto the chassis. So yes, it can come out, but it will not be pretty, and it will not be in one piece anymore.
Right. Okay. Well, we won't literally break it apart to get it out, because that will make a big mess, and
it will.
I think it probably won't be that smart. But really, the screen is just mounted there from the front. Is that right?
Yeah. So it's mounted through the front. It is taped on a bezel inside of the plastic, and then there is a single FPC connection that connects directly to one of the connectors on the digital board.
So there we have it. We have completely taken apart a RØDECaster Pro II and seen everything that is inside. I hope you found that interesting and illuminating. And if you'd like more information about the RØDECaster Pro II, check the links in the description below to a range of other materials and information on our website and our YouTube channel. I'd just like to say a big thank you to Pieter for coming in today and showing us everything that goes on inside the RØDECaster Pro II. And don't forget to stay up to date with everything from Rode. You can like and subscribe to our channel to get more of this type of content in the future. Thanks everyone, and happy recording. I guess there's really, Pieter, only one question left.
Which is?
Can you put it all back together again?